Lesson 11. Curl. Section 11.1. Relation between J and H. In section 10.2, we learned about Ampere's law, which is expressed by this equation. It states that the line integral of tangential component of H along a closed path CP, is equal to the current passing through the surface S, where S is bounded by CP. From this equation, we can determine H, based on the distribution of current density J. Conversely, if H is known but J is not, how can we determine J? The del operator is applied to a vector function H in the form of a cross product, and it is called the curl of H. It can also be written in this form. Using this equation, we can determine J from H. In the case of Cartesian coordinates, the del operator is defined by this equation. Then the curl of H can be expressed using a third-order determinant, as shown in this equation. Its expansion is the Cartesian expression of the curl of H. For the calculation of J, we only need to know local information about H. Exercise 11.1.1. Pause the video, and answer the problem. Find the curl of H at point P. The answer to exercise 11.1.1. This is a top view of I and H along the z-axis. The coordinates of P are given as x, y, and 0. Phi represents the angle of point P from the x-axis. The unit is radian. Phi corresponds to this angle. Then, the x and y components of H, denoted as hx and hy, can be expressed using phi. They can also be expressed in terms of the x and y coordinates. H can be expressed in Cartesian coordinates. The curl of H is calculated as shown in this equation. The result indicates that at point P, no current is flowing. Pause the video and review the answer. Exercise 11.1.2. Pause the video, and answer the problem. Find the curl of H at point P, where H is generated by an infinite plane current. The answer to exercise 11.1.2. Pause the video, and check the answer. Exercise 11.1.3. This is your homework. Pause the video, and answer the problem. Find the curl of H both inside and outside of the infinite cylinder V. The author of this material is Takeshi FURUHASHI, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.